Hi, today we're going to be learning about proving that triangles are congruent. First, I want to remind you about the minimum conditions for two triangles to be congruent. In order for us to prove that two triangles are congruent, we have to be able to prove that all three of their corresponding sides in the two triangles are equal to each other. So side, 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 or side, angle, side. That's where two pairs of sides in the two triangles are the same. And the included angle is the same as well. Remember, the included angle is the angle between the two sides. Or angle, angle, side. So we have one side and two angles. Or it can be angle, side, angle as well. One side and two angles in a different order. Or if we can prove that there is a right angle and the hypotenuse on another side are the same in the two triangles. Okay, so these are the different conditions for congruency that we can use when we are proving congruency. Now we're going to go and look at the actual method for proving that two triangles are congruent. It's not enough to just identify the case for congruency and say that they're congruent. We have to actually prove it. In order to prove that two triangles are congruent, we first have to identify which condition we can use to prove that the triangles are congruent. So we have to identify, is it side, side, side? Is it side, angle, side? Is it angle, angle, side? Or angle, side, angle? Or is it right angle, hypotenuse, side? So we have to identify which of those conditions we're going to be using. Then we have to set out our proof in a specific way. So this is the way we structure the proof. First, you name the triangles that you're going to be proving congruent. So you say in triangle ABC and triangle PQR, for instance, whatever the names of those triangles are. Then you have to have three reasons that you can prove that they are congruent. So it'll be a pair of sides that are equal with a reason. So if you've been told that they're equal, you just say given. Otherwise, you have to say how you're proving that they're equal. Or it could be a pair of angles that are the same, also with a reason that is valid for whatever you're doing, and then a third reason as well. So it could be three pairs of sides that you're saying are equal, or it could be two pairs of sides and an angle, or it could be two angles, or two pairs of angles and a pair of sides, or it could be a right angle and then two pairs of sides. So these over here will not necessarily be two sides and then two angles and then two angles. It'll depend on whatever condition you identified you're going to be using to prove that these two triangles are congruent. Once you have got your three statements with their reasons over here, then you're going to go and say, therefore, the triangle is congruent to the other triangle, making sure that you name them in the correct order, and you say whatever the reason was. So the case for congruency, the condition for congruency that you used over here. So because over here I had angle, angle, and side, it has to be angle, angle, side. Once you have proved that your triangles are congruent, you can then go and use the fact that they're congruent to say that other matching sides and angles are also going to be equal. So over here, we only knew that this pair of sides was equal, and this pair of angles was equal, and this pair of angles was equal. But now, because we know that these two triangles are congruent, we can now conclude that the other two pairs of sides are also equal, and we can conclude that the other pair of angles is also equal in the two triangles. So once you've proved congruency, you can then use the fact that those two triangles are congruent to conclude that other matching pairs of sides and angles are equal to each other as well. Okay, let's go and have a look at an example. In this example, we've got this diagram over here, and we need to prove that angle C1 and angle C2 are equal to each other. Okay, so now in order to prove that angle C1 and C2 are equal to each other, we have to, because they are, angle C1 is in this triangle over here, and angle C2 is in this triangle over here. If we can prove that these two triangles are congruent, then we can prove that those two angles are going to be equal to each other. So let's have a look at what we're going to do for this. Okay, so in this diagram over here, angle C1 and angle C2 are over there. In order to prove that those are equal to each other, we need to prove that these two triangles are congruent. So let's have a look at what we already know about the two triangles. I already know that this side is the same as this side over here. Okay. And I also know that this side for that triangle is the same as that same side for that triangle because it's the same side, it's the same line. Okay, so it's common. But I don't know anything else about these two triangles. I don't know anything about any of the angles, and I have no way of working out anything about the angles because I don't have parallel lines, I don't have vertically opposite. There's nothing I can really do to prove anything about any of the angles there, and I don't know anything about these two sides. So I can't prove straight away that these two triangles are congruent, which means that I can't prove straight away that these two angles are the same. But I've got more in this diagram that I can work with. If you look over here, I have these two triangles as well. Now, these two triangles I could potentially prove are congruent, which means that if I can prove that these two triangles are congruent, that means that those two sides will be equal. And if those two sides are equal, then I have enough information to prove that those two angles are equal. So I'm going to start off with these two triangles over here. So I'm going to start with triangle ABF. So I say in triangle ABF and triangles over here, A matches E, so E goes first, E, then B matches D, and then F. Okay, so I start off by saying in triangle ABF and triangle EDF. Now I'm going to have three reasons. My first one, first of all, let's go and have a look at what we do already know about these two triangles. So I know that these two sides are equal because they told me that. Over there. I also know that these two angles are both 90 degrees. They told me that. And I also know that these two angles are vertically opposite, so I'll be able to prove that those are equal. Okay, so I've got three pieces of information, and let's just check. So because it's two angles and a side, it's fine. I can use those to prove that they are congruent. Okay, so I've got over here, in triangle ABF, AF is equal to, in triangle EDF, it's equal to EF. Okay, so I also need to say these in the same order. So this over here is part of that triangle, so it goes first. And this is part of that triangle, so it goes second. Okay, so everything for this triangle is going to go here. Everything for this triangle is going to go there. Right? So AF is equal to EF, and the reason that I know that is because they told me. They told me that those are equal, so I can just say given. Right, so now I've done my first statement. The second statement is now going to either be those two angles or these two angles. So I'm going to do angle A equal to angle E, second. And the reason I know that, again, it's given. And here, because it's 90 degrees, I'm going to say 90 degrees is equal to 90 degrees, and that's given. The reason I'm saying that is just in case my case for congruency is RHS, I need to have stated that they're 90 degrees. So I'm saying that they're 90 degrees, given. Okay, then 3. The third pair of things that are the same in this triangle, in these two triangles, are these two angles over here. Angle F1 is in this triangle, so angle F1 equals angle F4 in that triangle. And the reason I know that those are equal is because they are vertically opposite. And vertically opposite angles are equal to each other. Okay, so now that I've got three statements with valid reasons for how I know that those things are equal in the two triangles, now I can say, therefore, the two triangles are congruent. So triangle ABF is congruent to triangle. Now I just need to make sure that I have got it in the correct order. So A matches E, B matches D, and F matches F. And the reason that I know that these are congruent is because I've got angle, side, angle. Okay, so now I've proved that those two triangles are congruent. Now, because those two triangles are congruent, that automatically means that everything else that matches in those two triangles is equal. So now I can say, okay, well, I know that these two angles are going to be equal, and I know that these two sides are going to be equal, and I know that these two sides are going to be equal as well. If you look over here, I'm looking at BF. Over there, BF corresponds to DF. So those two sides are going to be equal. So you can see over here, BF and DF, they are equal. I now have enough information to say that these two sides are the same over here, which means I have enough information to prove that these two triangles are congruent. Okay, so now let's go and focus on these two triangles. So now I'm going to go in triangle BCF, and triangle B matches D, so D goes first, then C matches C, and F matches F. Okay, so in triangle BCF and triangle DCF, now let's go and see what we can say is the same in these two triangles. So first, I have BC equal to CD. I know that those are equal because they told me that. Okay, so BC equals CD, and that is given. Okay, then I had already said that CF in this triangle is the same as CF in that triangle because it's common. It's a common line. So here I can just say CF is common. Okay, so I don't say CF equals CF. I just say CF is common. Okay, then my third reason is that these two sides are equal. So BF is equal to DF, and the reason that I know that those two sides are the same is because I just proved that these are congruent. So now I can say triangle ABF is congruent to triangle EDF as my reason for saying that these two are equal to each other. Okay, so once I've got my three statements with their reasons, here the reason is that they're common, now I can say that these two triangles are congruent. So therefore, triangle BCF is congruent to triangle DCF. And my reason for being able to say that is side, side, side. I've got three pairs of sides that are equal to each other. So side, side, side. Okay, now that I've done that, I'm not done because I haven't actually done what they told me to do. What they told me to do is to prove that angle C1 is equal to angle C2. Now, because I've proved that these two triangles are congruent, I can now conclude that the matching things in those triangles that we haven't already said are equal as well. So that means that these two angles will be equal, these two angles will be equal, and these two angles will be equal. The ones that we're interested in are C1 and C2 because that's what they asked us to prove. So now I can say, therefore, angle C1 is equal to angle C2. And the reason I know that is because I just proved that this is congruent over here. Now, I don't have to say congruency over here as my reason because it's following on from that. So it's a conclusion that I'm drawing from that. Okay. Right, so that is how you can prove congruency. You have to make sure that you set it out properly, that you have your opening statement where you name the triangles that you're going to be working with. You have three statements with reasons proving that the different things in the triangles are equal, and then you conclude saying, therefore, the two triangles are congruent, and you state what the condition for congruency was that you are using. Okay, and then once you've proved the triangles are congruent, you can then go and draw conclusions saying that other things in those two triangles are equal as well. Okay, so now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. Here you've got to prove that triangle ABC is congruent to triangle ADE. I'm going to give you 2 minutes for this question. Okay, so let's go through that example and see what you should have got. So first of all, anytime you're going to prove the two triangles are congruent, you have to have at least one pair of sides that are equal to each other. So if you look at these two triangles over here, we know that AC is equal to AE because they told us that. So that is one pair of sides we know is equal. There aren't any other sides here that they've told us are equal, but as long as we know that there's at least one pair of sides that are equal, then we can prove congruency if we have enough information about the angles. But we can't only prove congruency if we only have information about the angles. Okay, so let's just highlight that. We know that these sides are the same in these two triangles over there. Okay, now let's have a look at what we know about the angles. So I can prove that angle A1 and angle A2 are equal because they are vertically opposite. Then I've also been told that these two sides over here are parallel. Now, parallel doesn't mean equal, so I can't highlight the sides because they're not equal in length necessarily. I don't know that. However, because they're parallel, I can use what I know about angles with parallel lines. So I can say that I know that these two angles over here are going to be the same because they are alternate angles with these two lines parallel. So they're going to be equal. And I can also say that I know that these two angles over here are also equal to each other for the same reason. These two are alternate as well. Okay, so now I can choose which two pairs of angles I'm going to use along with a pair of sides, but I have to have the pair of sides as part of my proof. Okay, so let's go and have a look at what our proof is going to look like. So I need to start off by saying so this is question A, in triangle ABC and triangle. Now to name this in the same order. So A is the same as A. Then B is the same as D. And C matches E. Okay, so I've got in triangle ABC and triangle ADE. That's the start of my proof. Now we're going to go and start with our statement. So first I'm going to do the pair of sides that I know are equal. So AC is equal to AE. The reason I know that is because they told me it's given. So AC equals AE given. Okay, now we can go and do our angles. Now, like I said, we already know that all three pairs of angles are equal to each other because we have a way of proving each of them. So you can choose two of those three pairs of angles. It doesn't matter which two you choose so long as you choose two of them. Okay, so I'm going to use angle A1 and angle A2. So angle A1 is in this triangle, so it goes first, equals angle A2. And the reason I know that those are equal is because they are vertically opposite. And vertically opposite angles are equal to each other. Okay, so now I've done that. Now I can choose if I want to do this pair of angles or that pair of angles. It doesn't really matter. I can prove either one because they both are alternate pairs of angles with these two lines being parallel. So I'm going to do B and D. So 3 over here, angle B is equal to angle D. And the reason I can say that is because they are alternate angles with BC parallel to DE. Okay, so now because I've got a pair of sides and two pairs of angles that are equal to each other, I can now say, therefore, triangle ABC is congruent to triangle ADE. And the reason that I can say that, I used this side and that angle and that angle. So it's going to be angle, angle, side. If I had used this angle and that side and that angle, I would have done angle, side, angle. But it doesn't really matter because I could do either pair of I could do any two of the three pairs of angles. Okay, so now I've proved that those two triangles are congruent. They didn't ask me to do anything else. They didn't ask me to prove that any sides were equal or any angles were equal. So now I'm done with that question. Okay, now we're going to go on to question B. In question B, you have to prove that angle G1 is equal to angle G2. I'm going to give you 2 minutes for this question as well. Okay, so let's go through that question and see what you should have got. Right, so first of all, in order to prove that these two angles are equal, I have to prove that the two triangles that they're in are congruent. So what I'm going to do is first look and see what sides I know are the same. So over here, I know that this side is the same as that side, because remember, we can't prove congruency without at least one pair of sides equal to each other. Okay, then I also know that they are sharing this line over here. So the side over there and the side over there, they're common. Okay, so that's another pair of sides that I know about. Now, when we are proving congruency, remember, when you're working with more than one pair of sides that are equal, so if it's not two angles in a side like it was in the last one, if it's two sides and an angle, then you have to have the included angle unless it is the right angle. So over here, if it was the included angle, then it would be these two angles over here that I would have to know that are equal. But because over here, these two angles I know are equal, because they're a right angle, it doesn't matter that it's not the included angle. Because remember, we have a special case for right angle triangles where we can prove that they are congruent if it's not the included angle. So it's right angle and the hypotenuse and the side. Okay, so over here, I also know that I've got these two 90-degree angles over here that are equal because they told me. Okay, so let's go and do our proof. So I'm going to start off by stating which triangles I'm working with. So I've got triangle EFG. So in triangle EFG and triangle EHG, number one, I can say that in these two triangles, I know that EF is equal to EH because they told me. Okay, so it's given. So EF equals EH, given. Okay, next, I know that this side over here is common between the two triangles. So number two, I can say that EG is common. And then number 3, I don't know that these two sides are equal, but I do know that these two angles are equal, and even though it's not the included angle, it's fine because it's a right angle. So I can say that angle F equals angle H, and they are equal to 90 degrees, and that was given. Okay, so now I have got my 3 statements. Now I can say, therefore, triangle EFG is congruent to triangle EHG. And the reason I can say that is because of the right angle, hypotenuse, and side. So RHS. Okay, so now I've proved that these two triangles are congruent, but that's not all I was asked to prove. I was asked to prove that angle G1 is equal to angle G2. And now I know, because these two triangles are congruent, I can now say, therefore, the other matching pairs of things in the two triangles must be equal as well. So I would be able to say that this side is equal to that side, and I would be able to say that this angle is equal to that angle, and I can say that this angle is equal to this angle. And these are the ones that I'm interested in. So now I can say, therefore, angle G1 is equal to angle G2. And the reason I know that is because those two triangles are congruent, which I just proved. Okay, now let's go on to the next one. In question C, you have to prove that AB, this line over here, is equal to CD, that line over there. And they've told you that O is the center of the circle, and that's very important for you to know for this proof. Okay, I'm going to give you 2 minutes for this question as well. Okay, so let's go through that and see what you should have got. Okay, so now remember, in order to prove that two triangles are congruent, we have to be able to say that at least one pair of sides in the two triangles are equal to each other. Okay, so look over here. I haven't been given any information about any pairs of sides here, like I was in the last couple of examples, where they told me that certain sides were the same length. And I don't have anything that's common either. So I don't have any given sides equal, and I don't have any common sides. But they have told me that this is a circle and that's the center of the circle. So we're going to be using that to help us to prove that sides are equal to each other in these two triangles. The distance from the center of the circle to the outside of the circle is called the radius of the circle. And for a particular circle, it doesn't matter what direction the radius is drawn, it will always be the same distance, it will always be the same length. So this line over here is equal to that line, and it's equal to that line, and it's equal to that line. They are all the same length because they are all radii of the circle. Radii is the plural for radius. Okay, so I can say that this side is equal to that side. And I can say that this side is equal to this side. They are in fact all equal to each other, but I have to choose pairs of sides that are equal to each other. So I could have done that and that, and that and that if I wanted to. I'm choosing to do these two together and these two together. Okay. So I've got two pairs of sides that are equal. Now remember, when you are proving with two pairs of sides, we can't use these two sides of here because this is what we're having to prove are equal. So we know that they're not going to be part of our congruency proof. Okay, so there's no way of saying that those two sides are equal at this point. Now we have to have a pair of angles that are equal. I've got two pairs of sides that are equal. I need to have a pair of angles that are equal. Now, because there's no right angles here, it has to be the included angle. So let's just check over here. That pair of sides, the included angle is this one. This pair of sides, the included angle is that one. Can we prove that those two angles are equal to each other? Yes, we can, because they are vertically opposite. So these two angles are going to be the angles that I'm using in my proof. Okay, so now I'm going to go and start my proof. So I start by saying in triangle ABO, and triangle. Now, because I'm choosing to work with these sides together and these sides together, I'm going to say that these two match and these two match. If I was choosing to do it the other way, if I was choosing to say this one goes with that and this one goes with that, because I could, because they are still equal to each other, then I would have it the other way around. But because I'm choosing to do it this way, I'm matching A with D. So I'm going to start with D over here, and I'm matching B with C, so C goes next, and then O goes last. Okay, so I've got in triangle ABO and triangle DCO. But you could have it the other way around. You could have CDO, and that would be fine as well, if you were doing it the other way around. Okay, so my first statement I'm going to make is that AO is equal to OD. And the reason that I know that those are equal is because they are both radii of the same circle. So my reason over here is going to be radii. Okay, then I'm going to do the next pair of sides, which is going to work exactly the same. BO is equal to OC because they're also radii of that same circle. So now I know that these two sides are equal and these two sides are equal. Now I just need to do my angles over here. So now I can say angle O1 is equal to angle O2 as my third statement. And the reason for that is because vertically opposite angles are equal to each other. Okay, so I've got my three statements over here. Two pairs of sides and the included angle. So now I can say, therefore, triangle ABO is congruent to triangle DCO, and my reason is side, angle, side. Okay, so that's what we should have got for the proof. Now we need to go and prove that the two sides AB is equal to CD. So now because these two triangles are congruent to each other, I can now say therefore AB is equal to CD because it's the third pair of sides in the two triangles that must now be equal to each other because the two triangles are congruent. So therefore AB is equal to CD. So that's what we should have got for that example. Right, now we're going to go on to the last one for today. In question D, you need to prove that AC, this whole long line over here, is equal to BD. I'm going to give you 3 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so over here, this one's a little bit more complicated. You have to prove that AC, this line over here, is equal to BD, that line over there. So AC is part of this big triangle over here, and BD is part of this big triangle over here. So if we can prove that these two triangles are congruent to each other, then we can prove that those two lines are equal to each other. So looking at these two triangles over here, let's see what we already know is the same. So we know that these two sides are equal to each other, and we know that this side over here is common in the two triangles. So you could say, okay, well, maybe we can do side, 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 or side, angle, side. Now, side, side, side is out because our goal is to prove that these two sides are equal, which means that we're not going to be able to use them being equal to prove congruency because we don't know that they're equal yet. Okay, so side, side, side is out. Side, angle, side. So if I look at this side and that side, those are the two sides, and this one over here and that one over there in this triangle. But if I'm focusing on this triangle over here, remember, side, angle, side, we have to have the included angle. So if I've got this side and that side, then this is the included angle, and this over here is the included angle. Now I have a problem because I have no way of saying that these two angles are equal to each other with the information that I've got at the moment. So I'm not going to be doing side, angle, side. So what I'm rather going to do is I'm going to see what angles I can prove are equal to each other. So I can prove that because this is an isosceles triangle, these two angles are going to be equal to each other. So I can say this angle will be equal to that angle because that's an isosceles triangle, okay? So that's one pair of angles that I can say are equal. So in this triangle over here, that angle is equal to that angle in that triangle. Then, if you look over here, this is also an isosceles triangle, and this is an isosceles triangle over here, which means that these two angles will be equal to each other, and these two angles will be equal to each other. In this triangle over here, these two angles are opposite the equal sides. So this angle is equal to that angle. And in this triangle over here, these two angles are opposite the equal sides. So this angle will be equal to this angle over here. And because I already said that those two are equal, that means that these two will be equal as well. So I will be able to prove that those two angles are equal and these two angles are equal. And I have a side that is common over here. Or I could say I've got this pair of sides that are equal to each other given as well. Okay, so let's go and do our proof now. So I'm going to start off by saying in triangle ABC, okay, so A is matching D over here. So it's going to be D, then B matches C, so D, C, and then C matches B. So I've got in triangle ABC and triangle DCB. My first statement that I'm going to make is that I've got a common side over here. So BC is common. Okay, my second statement, I'm going to say that these two angles are equal to each other because this is an isosceles triangle. They told me that those two sides are equal over there. So I can say the angle that's in this triangle over here is angle C1. So angle C1 is equal to angle B1. And the reason I know that is because they are angles opposite equal sides in triangle BCO. Okay, and then I need to go and prove that these are going to be equal. Now this is going to be a little bit more involved because I can't just say it straight away. Okay, what I need to say is, first of all, this angle is the same as that angle because they are angles opposite equal sides in this triangle over here. So angle C1 is equal to angle A, because they are angles opposite equal sides in triangle ABC. Okay, I can also say that these two angles are equal because they're also angles opposite equal sides, but they're angles opposite equal sides in triangle BCD. So here I can say that angle B1 is equal to angle D, because there are angles opposite equal sides in triangle BCD. Now, because I already said that these two angles are equal, angle C1 is equal to angle B1, if angle C1 is equal to A and if angle B1 is equal to D, then I can say, therefore, A must be equal to D. Okay, so now I've proved that these two angles are equal over here. Okay, so now I've got a pair of sides that's equal or common. I've got a pair of angles that's equal, and I've got another pair of angles that's equal. So now I can say, therefore, triangle ABC is congruent to triangle DCB. And the reason over here I used was angle, angle, side. Okay, so now that I've proved that those two triangles are congruent, I can now go and prove what they asked me to prove, which is that the two sides AC and BD are equal because they are sides of that triangle that I just proved are congruent. So I can say, therefore, AC is equal to BD. And that's what we should have got for question D. And that is how we prove that triangles are congruent. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.